Welcome to Emerging Centers call number 34, March 15th, 2023. Our topic for this month is fair data practices, and we're joined by Christine Kirkpatrick from Go Fair US. I will start off by a quick introduction to the Campus Research Computing Consortium. CARCC advances the frontiers of research by improving the effectiveness of professionals in RCD positions, their career development and visibility, and their ability to deliver services and resources for researchers. As you can see from the slide, we have a number of different tracks with different facings, all looking at different aspects of the research and computing data environment. We also have a set of working groups that are looking at specific issues, including professionalization, stakeholder values and engagement. And then we have our operations group that manages everything and makes things go smoothly. The People Network of CARCC is a year-round remote conference with monthly calls in the different facing areas. This is the Emerging Centers area where folks who are providing leadership at their institutions, getting started in developing research, computing, and data capabilities at their institutions, and doing some initial leadership in their role, are discussing areas that are important to them. I'd like to ask you to, if you can, join in the Google Doc and sign in, make notes if you want while you're going. If you have any problems connecting, I think let me know. Otherwise, I think people are in there and editing, so that's looking good. And with no further delay, I'd like to introduce Christine Kirkpatrick of SDSC and Go Fair US.
Thank you so much for that introduction, Richard, and I'm glad to be here with you on the call, because if I wasn't, I'd be bailing out my driveway, which is flooding my garage, but it's going to wait till the top of the hour because there's not much I could do anyway. It's pretty crazy that if you design a system for no rain, just an inch of rain or less can really do a lot, it turns out. Well, let me first say to you, I'm one of you. I've been at University of California, almost all at UC San Diego, except for a short contract stint at our Office of the President for going on 27 years. I've been in IT a little over 30 years. I did work in industry, found my way to academia soon after, and just love the work-life balance, the stability, but really being around research and being around education, students, and I love the appeal of lifelong learning. I feel like I learn something new every day, sometimes things I don't want to know, but mostly things that are interesting. The first half of my career I spent in instructional technology. They didn't even call it that yet. And I've had a lot of assignments that no one wanted. I remember when someone said, could you do the World Wide Web? None of the Linux, or they were called Unix guys then, none of the Unix guys want to do it. So anyway, but about 10 years ago, I found my way to the San Diego Supercomputer Center, and I have to say research computing out of all the types of IT that I've done is my big love. So to all of you who are starting up centers, or maybe you've already started centers and now you're just trying to get more funding and people, you are in a great spot. What a wonderful spot to be in supporting researchers. So I'm going to talk to you today about everything fair, and for my instructional technology days, I'm going to claim parity on the use of this copyrighted material here. But I know there's so much that you have to learn about, and things, well, hopefully not things like PCI, the credit card standards, but there's some really horrible things that you get really tired of. There's yet another thing. And so I could completely understand, if I were you, FAIR would be probably in this category too. So I've really tried to focus on what I was asked to present on, which is chiefly what you would just really need to know, and how to help your researchers kind of see the value in doing it. So here's the case for it. And some of this is stuff that's talked about too much. If you go to a supercomputing conference, it's all fourth paradigm, but you know, there's this idea of different paradigms of computing, you know, and that it started out in experimental science, moved to theoretical, right? The apple falling on your head kind of stuff. And then we spent a few decades in computational science, the third paradigm, which is all about simulating things on supercomputers, et cetera. And that now we're in this fourth paradigm where people are just completely overwhelmed by data, but that, you know, things are very, you know, start out with and end with data. So this thing on the bottom, this is from a particular survey, but there were earlier ones done before we called them data scientists on how much time people doing data mining spent, you know, of the different things you could do with data. And the short story is, if you do anything with data, which is pretty much everyone in science, you're spending all your time doing stuff that once you know what you're doing feels highly clerical. And so as I started to work with scientists more and more and was seeing this problem up front, I thought, wouldn't it be nice if we could flip this so that people who have spent their lives, you know, training to do interesting things can do them rather than, you know, cleaning up spreadsheets. I think another thing that motivates me is here on the left, now we have things like ChatGPT, which are cool. And here I put in and asked it, how should I explain the FAIR principles to researchers so that, how would you do it? You know, and you could get kind of neat, pithy things out. But for any of you who have helped researchers work in data, it's kind of more of a giant mess. And you need a lot of specialized techniques that really depend on the domain you're working in, the resources you have, the skills of the people, et cetera. So if it's okay with you, rather than launching into FAIR right off the bat, I want to level set and make sure that when we're saying some of these terms, we all know what we mean. And I'm going to sneak in a few that you might have thought, do I need to know this? Well, yes, because if you start reading about some of these FAIR implementation concepts, you're going to hit some thorny words from information science, and I want you to know exactly what they are. And then I'll give you some practical stuff at the end after telling you a little bit about Go FAIR US also. Okay, so I think we all know what data is, but let's just level set. And this wasn't a cherry-picked example of data. This was just, you know, a random tweet that we got from our tweet feed, which is a mini commentary about all the garbage on the internet. But when I say data, I mean a discrete chunk of information. And so here in the right, this is a tweet, right? And it's got some finite information about a particular thing, which also has an image attached to it. This could be, you know, pictures, spreadsheets. It could even be, you know, temperature measurement off an instrument. Metadata, of course, is the data about the data. So most of this chunk of data includes a ton of metadata with it, you know, perhaps a location, the ID of the author, etc. Okay, so here are some of the most key concepts in semantics. And again, just so that you can understand some of these things, there are also terms that are used in other domains differently. So if you have a computer science background, you'll recognize some of these terms and think that's not how we use ontology, but don't worry about it. This is so that we can understand the stuff people put out about FAIR. So you can think of kind of a continuum of semantics, like the simplest semantics starting at making a list, and the most kind of advanced way of doing things would be an ontology, and there's some things in the middle. So I think we all know what a list is, but in this case, we kind of mean more a controlled vocabulary. So when you fill out a form, you're not allowed to just put in, like I can't just put in caliph or Cali. Not that we don't even say that in California. I don't know if anyone knows that, but okay. just an announcement to the nation there. But you know, we have a controlled vocabulary that makes sure that we're putting in the same thing for our state, and then it makes it easy to query. Okay, a glossary, and this is an example from the EarthCube office, which is just finishing up think we know what a glossary is. And here's our cyber infrastructure jargon glossary, right? Terms, definitions. Okay, a thesaurus. So you've used a thesaurus. Well, maybe some of us that are older have used the thesauri. But here we mean something slightly different. So some of my projects are in transboundary aquifers. And if I go to this cool tool from the National Library of Medicine called, I think it's called MeshB or something, and I type in aquifer, it's going to say, well, we prefer the term groundwater, and that here are all of these other terms that people use. But when we talk about this, groundwater is the grounding term. Okay, next up, the continuum, taxonomy. People use this word a lot in everyday language. Well, maybe geeky computing people like us do. But it does have a meaning in information science. And this is kind of to show you the hierarchy would be the easiest way to explain it. And I'm not saying that this taxonomy is perfect. I see some things I would disagree with there about, how they've included maybe philosophy next to some of these things. But you get the idea. It gives you a way of laying out terms in relation to each other. And this can be represented in a way that's machine readable. So it's not necessarily a picture. Usually it would be something that's in code, but you get the idea. Working all the way up to ontologies. And again, this is a term used in computer science that we don't exactly use the same way in information science, but, and I know it's small, but this is from BioPortal, which is a super cool resource. If you're in life sciences, ontologies are covered. If you're not in life sciences, if you're in computing, we're kind of out of luck. There aren't many good resources for this, but I did find one that kind of shows you, where does deep learning fit in relative to computer science? And it built this nice class diagram for me. And it even has mappings to, other ontologies and how these terms map between them. And this could be important if, say, you're collecting data about a certain disease, and maybe people across the world are creating or collecting information, but they're using slightly different terms. And so how do you map these terms? These are things that ontologies help you do. Okay, so the next part, now we'll jump into FAIR and a whole bunch of other terms that come up that people talk about. So hopefully everyone's heard of this, but if not, I wanted to make sure you have the words here, because if nothing else, people are often saying reproducible is the last one, and it's not, it's reusable. So we had a paper in 2016 by Wilkinson et al. That established the FAIR principles. It described things happening in research data management that had already been occurring, but it gave it a sticky term that said data, well, and really all research objects, it wasn't just about data, should be findable, interoperable, accessible, and thereby reusable. What I'd like you to take away from this, if nothing else, is that FAIR is not a specification. It's a thing you try to get to continuously, because the landscape changes, the tools change, the government guidelines change, your funders' guidelines change. And so it's something that you're continuously trying to do, kind of like electronic accessibility. Now, the difference there is that you can find a tool that will say, your website is accessible. But if you think of the ecosystem of a university and how you're constantly working to ensure it's still accessible, same idea here. It's definitely very domain specific. There's different ways that you would approach material science versus high energy physics versus geoscience, but there are also some things that cut across. And it's very much a work in progress. There are tools out there that will help you validate if you're fair. Most of them are kind of garbage. So, but don't worry, they're getting better all the time. And maybe some of you at your universities will find ways to make them better or start up new things. For me, the thing that gets missed a lot with FAIR is that it's supposed to help you create machine actionable research objects or data. And so by that, I mean, most data is created so that a person can consume it. But we have so much data, as you saw in that first slide, that we're never going to mine all the knowledge that we have unless we let the computers do some of the heavy lifting. And so, here's an example of a date. If I saw this in a spreadsheet, 3:30, I would probably think 3:30 p.m. and not think much of it. But, a computer needs to know, exactly what date, exactly what time zone, etc. Okay, here's some concepts that get tossed out related to FAIR that are important, but not exactly the same thing. If you've had any Zooms with program officers at NSF or NASA this year, it's the year of open science because they all have the fancy Zoom backgrounds, which is great to have the spotlight on that. Open science is kind of just what it sounds like, but to get a little bit more specific, here's a great definition from the Fisher paper, which means your technological architecture is open, people can get to your data, and there's some, democratization of access. Two key concepts. There was a Holdren memo put out by the Office of Science and Technology Policy. That's the arm of the White House that kind of gets all of the different agencies together to talk about things of commonality, which is important because we have a very decentralized situation compared to other countries. How we have Department of Energy, NSF, NIH, but this is a coordinating body that gets them and many more people together. And the head of that office, John Holdren, put out a memo 10 years ago that's to the agencies that said, you need to make the research that you're funding open. And then the agencies had to work out plans and report back and change some policies. Then just last year, we had a new memo from Nelson, and among other things that it does, it removes the embargo period on data. So it's pretty typical when someone publishes a paper that they can keep the data to themselves for a year and give them time to mine, I guess, things just on their own. So this says that by, I think it's 2024, maybe 2025, people need to have figured this out and made those changes. And so you'll see a lot of new language from the different funders, especially NSF, talking about open science, and they'll have probably calls for information as well as feedback on their plans for complying with these memos. So data validation and data quality, these are not part of FAIR, and they're not much talked about. You can have FAIR data that's just garbage, like my mom would say, garbage in, garbage out. But it could be beautiful and well annotated, but not be valid. And then reproducibility is another very important concept. Again, often people misunderstand the R in FAIR for that, and don't feel bad. It's easy to do. But reproducibility, in a nutshell, is this graphic at the bottom. It's not that you're going to run a process and get the same exact answer. It's that when you do an experiment, in our case in computing, that the outcome doesn't change the conclusion. And so when we talk about reproducibility, that's what we mean. In addition, it's not that you would repeat and get the same conclusion for your own science. It's that someone else could do it independently. And because the reason this is discussed a lot with FAIR is because in annotating your process and making artifacts like software, containers, your data shareable so that people can reproduce it, a lot of these actions also help it to become FAIR. So quick diversion on why I have this weird logo in the bottom of every slide. GoFair is an international organization organized around these three concepts that to help people implement FAIR in a practical way and to push ahead this idea that data and other research objects need to be machine actionable so that we can mine all of the knowledge that's locked in there. You need to have culture change, you need to have training, and you need to have technology that builds out that ecosystem of FAIR tools and services. GoFair has some unique things in how we try to go about this. First of all, we have these metadata for machines workshops, and these are really more active in Europe, but we have had some in the US. We hosted one last year for the geosciences through the EarthCube office. And what it does is it gets a group of people who are tasked with working with data, often people like yourselves, people in libraries, also researchers. And it's a training that also takes you through a process. And many times that will be creating what we call a FAIR implementation profile, where for your research lab or with a group of people in your research domain, you discuss, what are the standards that we're going to use for identifying people? I also work in metabolomics. So what are the standards we're going to use for giving unique numbers to metabolites, things like that. And then this third concept, that instead of collecting all of your data in a data lake or putting it somewhere, that people more and more should be able to leave their data in place and set up these FAIR data points that allow other things, APIs, mostly for machine actionable processes, to find the data, maybe do some computing right there and bring back the answers. So again, there's several national offices, but the center of gravity is definitely in Europe, with a little bit emerging in South America. We're hosting the US office at San Diego Supercomputer Center. I actually tried to talk some other people into doing this. I just wanted to be a member, but yeah, it didn't work out. So I'm running it, and my grand plan is someone is going to steal it from me. But having a great time. And the reason that we did this, we could have just, in the beginning, we just went to the meetings from the Netherlands, although it's not easy to get funding to always, go to Amsterdam, but they're actually in Leiden, close by. But we found that because of the center of gravity for FAIR, not just GoFair being in Europe, they're so much more well-funded to do these kind of activities. And we were finding a need to take what they had done there and translate it back for a US audience, where we don't have funders saying spend 5% of your grant on data management. Like, unless you have a NASA grant, you're never going to hear that. But I hope that changes over time, or maybe in a way that's palatable. So first of all, we work to establish a network of people who care about these things, get them working together, talking about what priorities are, giving a place for people to repeat trainings that have been held in other countries, new curriculums they've developed. And again, importantly, bringing back the messages from what's going on other places with FAIR, but in a way that's not unrealistic. So here's our office. We have people from around the country, people from, the other unique thing about GoFair US is we have really tried to integrate people from different backgrounds. So we have NIH heavy people, we have people from DOE labs, and then we also have a fourth pillar in the US called ambassadors, which is this recognition that over the coming years, 500,000 data stewards will be needed to be inside labs or inside companies to help make sure data is born fair. And so we have a group of people who've identified themselves as consultants. Nancy Hobel-Heinrich chairs the ambassadors pillar, and she's a specialist in earth sciences data. We also have someone who specializes in materials science, and that area is just growing. Okay, but all of that to say, what could you do? What are easy takeaways that you could do or help your faculty to do to make things more fair? And because I think reproducibility is so important and so integral, I've got this little plus symbol and have a few ideas there. So I've highlighted in red, and apologies if the contrast is not great. If you are not someone who sees red, that was not accessible to me. Just realizing, apologies. But I've highlighted here DOI, depositing, and metadata, because if you only see those three words, those are important takeaways. So a lot of FAIR, making data and research objects fair, is about assigning unique identifiers. A DOI is a kind of identifier that's usually minted by an authority, your library or maybe you can get one from Zenodo, etc. I deposited a preprint paper at archive.org, and that was how I got a DOI recently. So there's different ways to do that, but they're not just for papers, they're for data. They are for software, any kind of a workflow, any kind of research object that someone would need to find or be able to disambiguate from something else. It's also really important to deposit your data somewhere. And I know I just said on another slide, but you said we could leave our data in place and let it be visited. Well, sure, but you should have a record about that data and some very minimal metadata that describes what it means, because you looking at it might think, oh, the name of this CSV file makes it self-evident, but a machine doesn't intuit all those things that we assume are embedded. And I know you know this, but this is where you could work with your researchers to convince them of it too. Something that is not well supported by most tooling yet, this concept of recording provenance. So not only what is the data, where did it come from? You know, what instrument was it collected from? How was that calibrated? Did you clean the data? Did you do anything to the data, or is it raw? These are really important things to do as well. Some of the, if you look at so when I have the slide of the four words that make up the acronym FAIR, there were 15 principles that accompany that, and those are from that 2016 paper. Some of those are actually easy to do. For example, just including what the license is, that can people use this data? Do they need to use it with attribution? There's a great Creative Commons, gives you some easy to use licenses. You don't even have to figure out the wording, and you just link to it. And then another one that really helps with reusability and reproducibility is to provide a notebook. And in EarthCube, we did this. We have at earthcube.org, we have a notebook directory and a peer review process annually for coming up with new notebooks that the community can use. And they're wonderful because it shows you not just how the person did their science, but how they use that kind of data set, how they use that tool, and how they step through to come to the conclusion. So here's a couple of other easy things that you can do. There's 3 great data consortia. There, aside from GoFair and GoFair US, we have the Research Data Alliance, and we have CoData. And these are, if you Google them, or I can also put in the chat some links, but there are, I think, 80 different interest groups for the Research Data Alliance. Might be unfriendly times. I tried to join one recently and it was like 1 a.m. Pacific, but they'll sometimes move it if you identify yourself. CoData also hosts events with RDA and GoFair. And this fall we have International Data Week, which last year was in Seoul, Korea, and this year it's in Salzburg. Maybe not the easiest thing to get funding to go to, but we do have them in the US or in North America from time to time. And I'd encourage you to get on some lists and see the webinars coming by and attend 1 or 2. The second thing, if you don't already have an ORCID ID, it's easy to do. Just Google ORCID and set up a unique identifier for yourself. It'll automatically pull in any funding, publications. You can add your employment. And this is a great thing. There are more and more places will ask for your ORCID ID when you're doing something, or ORCID is kind of like in Common, where it's also a way, they have an API to use that as a login. And you can encourage your faculty. In fact, most of the funders now have something where an ORCID ID is involved. So this is probably familiar to many. This top right one is just a plea, easier to say than to do, but please, please, if you are working with someone who is creating new data, suggest they look and see if there's already some kind of vocabulary, taxonomy, ontology that they can already use. And that saves you time. Someone else has already thought about, what are all the possible terms, what's the hierarchy of the terms. And that makes the data much more interoperable and documents it without you having to do much. And then last but not least, and I will paste this in the chat, I hope you'll join our GoFair US mailing list. We only send out stuff every other month or when we have a webinar, but it's a way to keep in touch with all these other things I mentioned. because again, we try to make it about what do you just want to know, not everything that's happening. So specific to this group, I wanted to also give you some ideas for how to make your proposal more fair, because I think probably most of you look at things like the CC star solicitation and others and start to see the mention of fair. And it's like, well, wait, what does that have to do with networking? But certainly maybe more for the storage part. So the number one thing, spend time on your data management plan. And I have my own grants. I know how it goes, that you maybe grab a data management plan from your last proposal and you slap it in there. And that's okay. A lot of people do that, but just take a look at it, especially after the proposal's been mostly drafted, and make sure that things that you're talking about creating are mentioned with what you're going to do with them. I have this alpha tool that you can try if you're interested. It's called Ferris, which I know is a typo, but it stands for something, ferris.sdsc.edu. And it gives you it steps you through in survey format, asking you questions about what kind of research objects will your research produce, and gives you some ideas. But again, it's really in its infancy. This is another thing where I thought somebody must have made this already. Why can't I just go through and check some boxes like TurboTax and have it spit out what I should do in my data management plan? So it turns out nobody had made that. So anyway, so we did. If you do see something that you think could be better, we do have a feedback form, and it's here at tinyurl.com/Ferris. Gopher US is happy to provide letters of collaboration, and we have an easy process for this. If you go to our website, which is gopher.us, and click Get Involved, there's a link for a letter of collaboration. It gives you some check boxes of things that we could do for you, things that you might say in your proposal you're going to do in collaboration with us. We send you back a letter and a paragraph to put into your facilities document for those doing NSF proposals. And then for those of you that have university libraries, especially research libraries, often they will have an institutional repository where you can be depositing things. Once you have it set up, it's extremely handy, and that's how you can get your unique identifiers for things. And they are also a font of knowledge for helping with your data management plans. So since AI, or I really mean machine learning, or I probably really mean deep learning most of the time, but anyway, everyone says AI. So because that's so prevalent, I wanted to mention one last thing that I'm involved in. I have this research coordination grant that we call FAR, which stands for Fair in Machine Learning, AI Readiness, and Reproducibility. So we look at what's the relationship to the FAIR principles in machine learning? Are there things that you can do to your data that make the processing more efficient, or accuracy higher? They call this data-centric AI these days. The AI readiness piece is, what can institutions and data repositories do to be AI ready? What does that even mean? And then reproducibility, we talked about that a bit, but I don't know if you know, and I was kind of horrified as I learned this over the last few years. There's still a lot of variability in machine learning processing. For example, CentOS 7 had a bug in one of the libraries that caused a lot of erroneous results. And if you didn't know that, and you didn't run your computations on different kinds of clusters and different stacks, you would get results that maybe weren't completely accurate, which is fine if you're classifying, where's the 4-leaf clover in all these clovers. But if you're doing brain imaging or something, that's not good. And so what we're studying is, where is variance introduced? How can you document research that you've done with machine learning so that it's more likely others can reproduce it? And if you're interested in hearing about that, you can learn more at FAR with 2 R's -rcn.org. Okay, so actual last slide. Here's my info on the bottom right. Not using Twitter too much these days, but I will look if if I get an alert there. We do have Go Fair US Twitter, and that's how you can hear also about our webinars if you don't want to be on another newsletter. We do have a Slack channel, which is an easy way to get us and ask questions. I already mentioned the newsletter. Also, under the Get Involved link on our website, you can join as a partner organization, and we describe what that means, and it's free and pretty easy to do. Again, think of us if you need a letter of collaboration. We're always happy to promote what people are doing, especially in regards to their FAIR practices. And please give the Ferris tool a try if you're interested or have a moment.
Thanks very much, Christine. Is there a chance that we could get a link to the slides later?
Yeah, of course.
We'd had a question in chat. So I had a question. You had mentioned that it's early days for tooling for metadata provenance. Is there a place to look and sort of follow that development process and see what's out there? Do you have any recommendations there?
Sure. So that's something that we try to do at Go Fair US. Other than that, there are journals that you can follow. There's one from CoData called the Data Science Journal, which was named before there was data science. It's really the science of data. But anyway, they nabbed a great name. They have articles a lot that talk about the different tools or announce new tools. EOSC, the European Open Science Cloud, has had a few projects where they compare these tools, but it's even early days for having a clearinghouse for these kinds of things. And so on our website, you won't see a lot of links to use this tool because most of them have a lot of gotchas to them. For example, there's a really good tool that came out of an NIH project called FairShake, which can do some, it can look through your data repository to say how fair is what you've posted here. But many of the controls are manual. So if you are using the tool and don't know that, it will look like you failed in several areas that you've passed because you have to do something. So anyway, again, I go back to electronic accessibility because I think that had a similar arc, and it was really hard at first, and you had to have people that specialized in it, and the tools became more mature over time.
So we also have a question in chat from Jacob saying the NSF has test beds for hardware and software, and for the goal driven by FAIR to be met, I think there needs to be a repository accessible to the public. Is anyone aware of the existence of a public repository for these test beds, I think?
Well, I mean, that would be nice, but no, there isn't much funding given to FAIR. The NSF has had exactly one call, and I have one of the grants from that call, which established research coordination networks. So they're not even to do infrastructure for FAIR. It's been a real afterthought. At first, I think people thought, well, the libraries will worry about this. Well, the library can't worry about it at the end when you're depositing the data. You have to be working on FAIR from the start. And so hopefully some more funding will follow. NASA's had the Year of Open Science, and they've had small calls, but they put out calls for things that are like $100,000. And so, and I'm not trying to sound like a snob, it's just 150-page proposal to get $100,000 isn't too exciting for a lot of people. But well, I think you heard me say a couple times, I thought someone had already done this, so I had to, and they hadn't, so I had to do it. So this could be, if CARCC wants to get into this, I'm on board. We can work on this together.
All right. Any other questions for Christine?
Hey, I have one. Can you hear me okay? I'm on the phone.
Yeah. Mm-hmm.
So I'm a researcher, and I just actually got out of my medical bioinformatics class, and I did once again explain the difference between storage and RAM, and I talk about words like metadata and stuff, and it's kind of sinking in. It's very difficult. Is there like a good, kindergarten level primer for like words like metadata Jupyter Notebook. These are very advanced concepts for people who are terrified of computing, who are generating the data.
Yes.
Like any kind of like,
Yes.
baby step kind of tutorials. I'd love to share that with my students.
Sure. Well, the first one that comes to mind, it's not interactive, but it is the cyber infrastructure jargon list that we developed for EarthCube. And I can put the link in the chat. And we developed this because we were, so let me say EarthCube, it was an NSF program, spent about $85 million on different projects that tried to bring cyber infrastructure people, computer scientists, and earth scientists together so that, the geosciences could have the latest, tooling and techniques. But we found these things stumbling blocks. Like, what do you mean a notebook? I use MATLAB. Like what? And another good point is some of these things have come about after people have done their training, and so there's a have and have not just with people who don't feel technical, but sometimes mid to later career faculty were like, I got trained on a whole other set of tools. I never had Python. Like, help me get back into the stream. At Go Fair US, we've been working with our partners in the Netherlands to try and bring an introduction to these concepts. We've attempted many things and they were all too involved. Again, this is the European approach of here's 40 hours on this topic and do this homework first. So I can't point you at anything that's wonderful. We've had a few webinars that I thought were particularly good, but again, tuned at specific audiences. If I can think about it and I get an aha after the call, I'll send something to the meeting organizers to share with you.
Yeah, that'd be awesome. I'm really thinking about like dedicating one class to a primer, glossary, cheat sheet for really basic things. I remember these people, like I spend probably I'm halfway through the semester and I've got most everybody understanding what a file is now and a file system. And like the concept of a text file is I still think about half of them don't understand what I mean by a text file. And again, these are the people that are generating, eventually going to get $1 million grants and generate all sorts of NIH funded data, right? But they have no concept of even what the very basic concepts are, what you're talking about. So anything like that would be fantastic. And you can share it with, I'm not gonna be able to see chat, but just through the Google Doc or something like that would be great.
Sure, yeah, of course, but there are things embedded in like Coursera or edX classes, but I'm just trying to think of just the nugget that I know you need. So let me do some homework.
I'd like to, excuse me, I'd like to add on to what Alex is saying. Sorry, I'm sick, but I'm just trying to be a fly on the wall. But this is so poignant at this moment. Working with the RCD community builders, and funny, it's been a discussion. It's come up more on the library side of the house. And library information science is to have a CI 101, a primer on terms, but also concepts. So I think, Alex, it sort of gets to what you're saying too, to those who are new to this area and this profession. How can we support them in their growth and their understanding of these areas? So this jargon list is fantastic. I think we're also looking to seek out other basic introductions to cyber infrastructure use that might go well towards not just the library, the information science side of the house, but also for just new users altogether.
Yeah, I would say in the arc of my career, that's the one unifying thing of trying to take complicated things and make them accessible, and really disliking people getting left out just because things sound too complicated. And so I think that would be really important. I know the DCCs, the Data Stewardship Competency Centers, have some of these resources. So let me take a look at past lists we've given out to people and see if any still track.
Thank you. Appreciate
and I hope you feel better.
Thank you.
Okay, if there's no further questions, Christine, thank you very much for joining us. This has been really great. I really enjoyed it. Was taking notes the whole time. Hopefully, folks chip in with some more links. But there's a lot of good stuff in here. So I really appreciate you coming and talking to our membership about Go Fair. This has been really great. So thanks again.
Yeah, no, thanks for having me. And I hope I can come back to CARCC. One area that I think in particular CARCC could be a leader in is that, again, you would think it's already been done, but giving unique IDs to systems so that they could be cited. And that's that 1 a.m. meeting I can't make of the interest group. But I'd like to bring some of these ideas to the US and work on it with a group like this, because it's kind of silly, this idea that you're going to write a 10-page paper so that now you can refer to a cluster that you have on your campus. And, let's just give it a number and know what it's, have a description of it somewhere.
As a person who's been charged with writing some of those papers, I definitely think that would be really helpful for, papers and projects and things like that, where there's no good, citable summary. Having something like that would be a real boon, to not have to produce some kind of scholarly work that just describes something. So
Agreed.
I'm tentatively on board for that one.
Okay, awesome. Well, let me see if I can, again, distill what's being done into something actionable, and I'll come back to you all.
That's great. Okay. Well, thanks everyone. We do not have a topic on board for April, I believe. So if you've got ideas for topics for the April call or for future calls, things you'd like to see, please feel free to write the Emerging Centers mailing list, or join our steering committee, or sound off on a call and tell us what you'd really like to hear. Thanks again, Christine. We really enjoyed having you here, and we hope to hear from you again soon. Take care,
Awesome.
everyone.
Thanks so much. Take care.